Implicit differentiation. Consider this equation, x square plus y square equals 1. Notice that y is not given explicitly as a function of x, but it's mixed with x square on the left side of the equation. So whenever you have an equation where y is not explicitly written as a function of x, you say that y is implicit in the relationship. And what we assume is that y is a function of x, and we try to find the derivative of y with respect to x. So what we do is we take the derivative on both sides of the equation. So if you differentiate on both sides, you take dx of x square plus y square on the left and dx of y of 1 on the right. Now notice, according to some rule, you can simply take the derivative of x square plus the derivative of y square, and the derivative of 1 is just 0. So let me write it down. Now here we know derivative of x square, we are taking the derivative with respect to x, so this is going to be 2x. Now the derivative of y square, it's not with respect to y, this is with respect to x. So we want to think of this as a function, y itself as a function of x. So what you have is a composite function. Y is a function of x which is being squared. So the outer function is square. So you would have 2y for its derivative, but again y itself is a function of x, so we want to say that we have to multiply with the derivative of the inside function, which is dy over dx is equal to 0. So long story short, the derivative of x square is just 2x, but the derivative of y square would be not just 2y, but 2y times dy over dx, because we are taking the derivative of y with respect to x as well. We are applying chain rule. And now we can do the algebra. We subtract x from both 2x from both sides, dy over dx equals negative 2x, and you divide both sides by 2y and simplify, you get dy over dx equals negative x over y. All right, let's do one more example. So say I have something like x cubed plus 3x square y plus y cube is equal to 5. Now let me not write d dx, I'll just write down the derivatives. The derivative of x cubed is just 3x square. Here I have to apply the product rule. So I want to think of 3x square as one factor and y as another factor. So if I take the derivative of 3x square, I just get 6x. I'm applying the product rule. So differentiate and fix. Plus, now fix the first one, 3x square, and take the derivative of the second function. So the derivative of y is dy over dx. Plus, now y cube's derivative is not just 3y square, but you have to multiply by dy over dx as well. Equals the derivative of 5 is just 0. So now let's collect all the dy over dx terms on the left. So I have 3x square here plus 3y square. And let's move the other terms that don't involve dy over dx to the other side. So when you move them to the other side, they become negative 3x square, and that becomes negative 6xy. It's like subtracting 3x square from both sides and subtracting 6xy from both sides. And finally, to get dy over dx, we just have to divide both sides by this expression. So let's write down negative 3x square minus 6xy over 3x square plus y square. And if you care to simplify, remove the common factor, then oops, sorry, 3y square. Then you notice that 3 is a common factor in both, and you can actually factor a negative as well. So it would be negative of x square plus xy over x square plus y square.